This video is on principle of mathematical induction. So when we're talking about mathematical induction, it is a mathematical technique which is used to prove a statement, a formula, or a theorem is true for every natural number. So the first thing is we have to show that n, or we prove that n equals 1. That is the first term. So from there we can show that n equals k, and then further to show that n equals k plus 1. So let's look at this example. Proved by mathematical induction, Sn equals a open bracket 1 minus r raised to power n close bracket over 1 minus r. So from there, don't forget the first thing is we have to show that n equals 1, okay? And let's look at the series. That gives a, that is the first term, equals or plus ar square plus, so we have ar, that is the last term, which is n minus 1, that is we subtract 1 from the number of 10. So we have, so this will give equals a into 1 minus r raised to power n, and n is 1. So over 1 minus r, so this equals, this cancel this, equals a. So n equals 1. So we prove it to be a, that is the first term is a, which is a according to what we have here now. So from there we can proceed further to show that n equals k. So the series a plus ar square plus, can have plus ar raised to power, what, raised to power n minus 1, and because n is k, that is k minus 1. So this is minus k minus 1. So from there, and that gives a into 1 minus r raised to power k over 1 minus r. Okay, so from there we can proceed further and show that n equals k plus 1. So anywhere there's n, we put k plus 1 there. So let's look at the series, and the series that is a plus ar. So you can have a plus ar square plus 3 dot ar, okay, raised to power k, this is k minus 1, plus, so the next term, which is ar raised to power what? That will be raised to power k. Okay, so we now have this equals, so don't forget when we put the value of n here, the power here, which is k minus 1, and n minus 1, by the time we substitute n for k, and because k is because n equals k plus 1, so by the time we substitute the value of n for k, that will give k here. Okay, so here we have a into 1 minus r raised to power what? Raised to power n, and n now is k plus 1 over 1 minus r. So from here, that is when n equals k plus 1. So from there now, we've already proved this one before, that what we have here, okay, this one here is equal to a into 1 minus r raised to power k, okay, over 1 minus r. Now this plus is this, so we add it to this, which is ar raised to power k. So we can put over 1 here. So from here we are going to prove that the left hand side is equal to the right hand side. So this is the right hand side, which is a into 1 minus r raised to power what? Raised to power k plus 1 over 1 minus r. So this is what we have to prove. The left hand side is equal to the right hand side. So let's look at the left hand side. So we can take the LCM of the denominators, which is 1 minus r into 1 minus r goes to 1 minus r, that is 1. So 1 times a, that is a into 1 minus r raised to power k, plus 1 goes in 1 minus r, that is 1 minus r. So multiply it with the numerator here, which is a raised to power ar raised to power k. So from there we can open the bracket. So let me clean this side. So multiply 8 and 1, that is a, So you can have minus AR raised to power K, so plus, so AR raised to power K times 1, that is AR raised to power K, okay, so minus R times AR raised to power K, that is A, so just pick one R and add the power according to law of indices, so that is K plus 1. So from here we can have over 1 minus R. So AR raised to power K plus A raised to power K, so that cancels out, and we have A minus AR raised to power K plus 1 over 1 minus R. So from here we can factorize A out, so we have A into 1 minus R raised to power K plus 1 over 1 minus R. So from here now, we've proved it that the left hand side is equal to the right hand side. Thank you. Please, if you've not subscribed to this channel, kindly do so.